Good evening. So I'm here talking about my favorite subject over the past, I think, 3 or 4 years. If you've seen me before, you might have heard me talking about this thing called TLS and certificates and whatever. Today's topic, your connection is not private, might be a phrase you've seen before. And what we are going to do is exploit insecure certificate validation in TLS clients. Before that, a little bit about me. So my name is Aapo. I'm a senior security specialist working at Nixu, and my day job revolves around devices and IoT and whatever. I do quite a lot of cryptography, not the actual math part, but the implementation part and these kind of things that are easy to break. Also work with network protocols. Quite a lot of custom protocols are involved in this IoT and quite a lot of different kind of network things going on. So not only protocols, but also networks and systems as a whole is kind of what I do at work. But after that, when I get home, security research is something that I really like to do. Bug bounty for the past, I think, 3 years has been this kind of hobby that I think at home it's like there's not everyone at home appreciates the long nights and weekends spent on this kind of computer stuff that I'm already doing at work, but that's something that I really enjoy. Additionally, this thing called challenge.fi has been part of my hobbies for a couple of years now. So doing challenges, CTFs, trying to do trainings for the young ones, so under 25-year-olds. There are some here watching this, and I have been the ECSC Team Finland coach, so this European Cybersecurity Challenge, which brings the young ones from all over Europe to compete with each other. But the topic today, that is TLS. You might know what that is, but if you don't worry, I'll keep this simple. When you're using computers, there's something that you want, and that's kind of you might want it inside the computer, but of course, usually, if you don't create it yourself, it's somewhere else. And here is a computer and a server. And there's some kind of connection between those. So a wire or wireless or whatever. But this is kind of not really the complete picture of what's happening. So between you and the server, there is this kind of big mess called the internet. I think there's been books written about that. But that's basically a bunch of computers trying to figure out how to kind of get you what you want. And in the internet, and I think here tonight, there are some bad guys. So there's a problem. We have this big mess, complete with computers, networks, bad guys, whatever. And there is something that we want on the other side. And this kind of is the core problem that TLS is going to solve. And TLS, Transport Layer Security, I think it comes from the kind of, it secures the transport layer. So transporting data securely from somewhere else to you and you to somewhere else. And this is simple. Bad guys can't get in between me and what I want. So basically, that's how it's supposed to be. It should end here. So we are using TLS, everything is secure. But I think you might have guessed, it's not that simple. TLS, I've simplified it a little bit. We have the channel, but remember there's the bad guys somewhere in between. So we need authentication, we need encryption. We need to encrypt the data so that only we can know what the data is. And we need authentication so we know that the data is actually coming from somewhere else. In other words, the server is actually where I want to connect to. And the data is actually what I want to get. So no one can go in between and modify it, do this kind of man-in-the-middle attacks, or even read the data from the internet. A little bit simplified. Authentication is done with certificates, and encryption is done with cryptography. And we are not going to talk about the cryptography part today. So that is something that is really hard, and lots of brilliant minds have been working quite heavily in making that as bulletproof as possible. But the certificates, that's kind of doesn't require this complex math and whatever. So the brilliant minds haven't looked at this, or at least this is what I think has happened. You might have come across these kind of certificates in the internet, and I think this is the kind of main connection between normal people and TLS certificates. So HTTPS is basically HTTP over TLS. And there is something wrong with the certificates. Usually it's someone has just forgot to renew the certificate, so it's too old. So it's a correct one, but too old for some reason. And there's kind of a million different ways how certificate can be invalid. And this kind of, you just click the proceed. So you just don't really think about it and proceed. But remember, it tries to warn you in the bottom there that it might be a misconfiguration or an attacker intercepting your connection. So next time you want to click proceed, you might want to figure out, like, there might be a bad guy trying to attack you. And this is kind of the thing with certificates. So browsers have been doing certificates for a very long time, and they are pretty good at it. So some brilliant minds have been working with certificates in the browsers. But let's see. These certificates are basically kind of a thing that certifies something. That the holder of this certificate is someone, and they are allowed to do something, and there's someone who has given you this certificate. So you might have like a driver's license that says that, hey, your name can drive a car, and it's signed by the police or whatever. Or you might have something like this, that is obligatory memes. But yeah, there is something kind of, someone has been certified to use the force by this handsome fellow called Gandalf. But if we need something else than just the name on the bottom. So there is actually a way how to make these certificates kind of valid in that So we have a certificate, and we put a signature on it. So this is a valid certificate now that it has the signature. We can a little bit look into like what actually is a certificate. So this certificate, it's basically a fancy text file. So if you try to open it, you might see something there. But if you kind of open it with the correct tool, you might see these kind of fields in the certificate. So the certificate is issued by someone. It's issued to someone. And there is this public key cryptography there that you can use it to sign electronic things. You might have some miscellaneous things in the certificate, and this is kind of one thing that makes these certificates have a lot of problems, because it's not specified in the specification like what everything can be in a certificate. So it can be basically anything you want. And then there's a signature. So we could have a certificate issued by Aapo, issued to Aapo, with this kind of public key file. It could say, hey, this is Aapo in the certificate, and it includes this signature file also. And if you know your RSA cryptography, you have a public key and a private key. So this is kind of another file. On top of the certificate, you have this key file. And the key file basically says that if you have the key file, then you can use the public key in the certificate. So it kind of proves that you actually own the certificate. So even if you give the certificate to someone, they can't use it without your key. So we created a certificate and a key. And we talk a little bit about these signatures. So something that proves that this is not just Gandalf giving out certificates, but it's actually a valid thing. And these kind of signatures are given with these keys. So we have the aapo.pem issued by Aapo, and it's signed by Aapo. And then you have the server certificate that is also issued by Aapo, and it's signed by Aapo. So if I really trust the server, I can give it a certificate that, hey, you are a server signed by Aapo. And the server has its own key that it can use to prove that it is actually the server. A little bit like this. So there's the me, now with my certificate, and the server with its certificate. And how this TLS works, I want something from the server. So I want it, and I want only it, and I want it only from the server. So we can use this TLS with these certificates kind of like this. So with our certificate, we can check that the server actually is the correct one. So when we start a TLS connection, we are connected to someone. And when we have done the connection, we can then ask the server to verify that, hey, we are now connected to you. Who are you? And they can say that, hey, I am the server. And the server uses its key to kind of make the proof in the TLS connection. And is it now the end? Well, let's go back to this slide. If you can't see it, we can zoom a bit and enhance. And what does it mean that the server, or that we can check the authenticity of the server? Like, we are using this TLS connection. We really want to kind of authenticate the other party. So why is it that we can check the authenticity of the server? Well, it turns out certificate validation in TLS is optional. So to ensure that you are really connected to the correct server, you have to validate the certificate if you want. So kind of like this was, when I started studying TLS, this was a little bit new to me. Like we want secure connections. Why would we not want secure connections? And of course, as we talked earlier, browsers, they want secure connections, and they are checking the certificates. But when we are talking something else than the browsers, you might remember from earlier, I talked that I work a lot with devices. So some kind of IoT device. And they want secure connections. But if you are developing some kind of IoT or application, you might want secure connections. But are you really validating the certificate when you're doing so? So you might want to think a little bit that if you are someone who is actually developing these things, have you put some thought into this? And I can say not a lot of developers have. If we remember a little bit about the certificates, so this is kind of 3 things that you should check from a certificate. So when you get a certificate from a server, you should check that who has issued the certificate. We don't want Gandalf giving us server certificates. And we want to check who the certificate is issued to. This is kind of what you do at the bars. You look at the picture and you look at the 12-year-old kid and you check, doesn't look like the picture. And that has the certificate being signed. So is it just a forgery that says something like this? And if you look a little bit closer to each of these, so who has issued the certificate? Basically, in the internet, there's these kind of different parties that issue certificates, like GoDaddy and Let's Encrypt and etc. There's like 1,000 different places who give this out. And if you are working with the kind of really important stuff, that you might not want all of those 1,000 certificate issuers to kind of issue certificates. So you might only trust kind of some of those. And there is this special thing called self-signed certificate. So we created the aapo.pem certificate that has signed itself. So if I'm really strict about my security, I might only trust that certificate. So if I have 2 computers and I can kind of share the certificate, so I can use the same certificate or whatever, and I can just trust it and nothing else. And this is quite handy when you are developing things. So you just put a self-signed certificate and you trust it. But are you trusting only that self-signed certificate or something else also? There's the question of who is the certificate issued to. So it could be issued to Aapo. It could be issued to my website. It could be issued to whatever. It might be kind of, it doesn't specify in the specification of the certificates that what you can actually certify and what you can certify them to do. So these kind of questions that if you just change your name to like kim.com or whatever, then get a certificate for your name, and then you might have a certificate for a website. So these are also something that we want to check. And especially we want to check that if we are trying to go to aapo.com, that the certificate is not for bob.com or whatever else. So we want we want the certificate to be issued exactly to the thing that we are connecting to. And that has the certificate been signed. So this is also some math, and you don't really have to understand how these signatures work, but you just need to know that, hey, it has to be signed and the math has to work out. And luckily there's tools for this. And if we want to attack against this kind of certificate validation process, so if we are checking that who has issued the certificate, so if we just self-sign a certificate and the other party doesn't check like who has issued it. So if we just issue a certificate to whatever, apple.com or something, and just issue it ourselves, if this is not checked, then that's a valid certificate. And who is the certificate issued to? So if you don't check this, there is this thing called Let's Encrypt that lets you have a certificate in 5 minutes for something that you own. But if it's not checked that who owns the certificate, it's a valid certificate for me, but it's not a valid certificate for apple.com. And that has it actually been signed. So we can craft some kind of certificate that has our public key and our private key can then use it. But the signature is just not valid. So we can say that, hey, GoDaddy has issued a certificate for apple.com with my public key. And I can say that, but you should check it, that is it actually true? And if you don't check it, it doesn't have to be true. And this is kind of the time for a little quiz or a test. So this is kind of a code from something. So it says certificate validation. The function is called certificate validation. And this does something. So apparently it checks if the certificate is good. And if it's not good, it returns false. And if it's good, it returns true. So it's kind of a true or false question. I'm not sure if you can see it well, but I can highlight these things. So it does not check who the certificate is issued to. It checks that, hey, there is a certificate, but it doesn't check who it is issued to. It does not check the signature. So it checks that there is a certificate and there is a text in the certificate that says that, hey, this is issued by this kind of trusted certificate authority. So the certificate has to say that it's coming from this party, but this code does not check if it's actually coming from there. And then if these checks fail, like we should return false. But as you see, it returns always true. So there is no return false anywhere in the function. So certificate validation true. Like this is kind of, and this is a real example. It's not from this kind of very used program or whatever. It's this kind of hobby thing for someone. If we scroll up in the file, we can see exactly where it's from. So it's from this kind of startup called Microsoft, from this application called Intune. So I don't use Microsoft, so I don't really know what exactly Intune does. But apparently it installs stuff on your computer with system access remotely. And this was a, let's go back to the dark theme. So in 2021, so Microsoft Intune Management Extension Remote Code Execution Vulnerability. Just because all certificates were accepted. So I could pose as Intune management server and just install a bunch of stuff on our company laptops, and that was fun. But kind of enough talk. So there is this kind of checklist for us to do. So let's self-sign the certificate. Let's get a valid certificate from someone else. And let's craft a certificate with our public key and set the issuer as someone trusted and just not sign it properly. So let's try out a demo. Let's see. Let's see. There's some. And you will see something in just a minute. And then we need to do this. Some demo effects affecting my stuff. Yes, so let's see. So here is a live terminal. Let's all be silent for a moment and pray to the demo gods that everything works out fine. Yes. So we have this kind of command. OpenSSL is an excellent tool if you really hate life. But it gets the job done 9 out of 10 times. So we can get a kind of certificate request from ourselves that, hey, we want a certificate for example.com. And we are creating a key, and then we are kind of signing the certificate. So now we have server.pem, server.key. So you can try this at home, and you will have your own certificate in just a few clicks. And with this other command, we can check the certificate, so we can print it out in text format. So this is now the certificate. So this is a text view of this kind of quite complex X509 format. But as I said, there is some kind of bunch of text data here. So we can see that there is some kind of issuer issuing our certificate. So in this example, we have the example.com, and the subject of this certificate is example.com. So this is what we call self-signed certificate. There is also the RSA key. So this public key shown here. This is the math part, don't worry about that. there's also some bunch of stuff here that sometimes breaks some systems, but we don't really care for that. And then there's the signature. So it says that it has been signed with this SHA-256 algorithm. So this is basically our certificate. So we set out to create a certificate, and this is basically it. We also had another mission. We wanted to get a certificate from somewhere else. So I've done this offline. I got a certificate for a domain from Let's Encrypt. And so we have the TLS test certificate, and with the same command we can view it. So now we have the issuer Let's Encrypt, and it has issued a certificate for this common name. So we have the TLS test.di.fi. So you can get free domain names from the do.fi, and then you can get a free certificate from Let's Encrypt. So everyone can try this at home for free. And then when Let's Encrypt creates certificates, there's a bunch of other stuff that it wants to put there. So this has been a headache for someone to actually figure out how to parse all this and what to do with it. And we're not today not so focused on this, but there is kind of 10 more ways to break TLS certificate validation hidden somewhere in this. But our mission was to get a certificate, kind of valid certificate from someone else. And then the hard part was to kind of get a certificate and modify it so that we have a good certificate, but it has our key inside of it. And for that, I had this kind of small program, uses Python's OpenSSL as bad as the command line version. And it opens the TLS test certificate, loads it into the OpenSSL, and then we have a key that we have generated, and we just set the public key of the certificate with the key. And because OpenSSL is a bad software, we also have to sign it. We actually don't have to sign it, but if we use OpenSSL, then we have to sign it for it to change the data, because it's a bad program. And then we just write it out to a file, and there we have it. So we have a TLS test certificate, and we have the same certificate with a new key. So we can check the differences with Vim, of course. Handy one-liner for this. And what we see is that we have a certificate, the original on the left, the new one on the right. So we have a certificate for tlstest.do.fi that has a different public key, but everything else is the same. So all of this data is same. The signature has changed, but because we are assuming that this is not going to be validated, and even if we don't change it, it will be wrong, because the signature is for the original certificate. So we now have this, and we have now 3 certificates that we can use. And I picked these 3 because these 3 give good results when you are doing some security testing. And with these certificates, we can start to kind of do bad stuff. So I have this kind of command here. So I have a DHCP and DNS server running on the upper window, and then I have a console here. So what this is actually doing is that whatever connects to us, we are giving it an IP address, and we are providing a DNS server for it to use for whatever it wants. We have the address parameter, so if it specifically wants to download iOS apps, we will give it an IP that is our IP. So basically, we have this kind of network that anyone can do anything that they want, but if they want to download iOS apps, they will have to go through the 10.001. And then there is this kind of command. So socket is a command for listening to kind of connections and making connections out. And what we are here wanting to do is that we want someone to connect to us with TLS using OpenSSL, because yes. And we have the server.pem and the key.pem that we generated just 5 minutes ago. And when someone connects to us, we don't want to verify their identity. We trust that they are someone that we want to steal from. And when someone connects to us, we will redirect them to iosapps.itunes.apple.com. But we will, of course, log the traffic. Because we are terminating the TLS, we, of course, can peek inside. And let's see. So on the right here, I should have an iPhone. Let's see. Yes. I'm giving a passcode. So here is the Apple App Store. Let's see what we want today. So this looks like fun. No. Let's see. There is something wrong. Let's try again. Maybe this one? No. No. There is a Ethernet cable unplugged. Let's see. We plug in the cable. We might see something on the upper window. Or not. Yes, there is Jamie. And Jamie wants to connect to the internet. So let's go to some app. I don't know how to use Apple. Let's see, there's apps. Let's get Snapchat. So now we are downloading Snapchat. And we are waiting for someone to want to connect to the iOS apps. So it's thinking for a moment, it's going to different servers, kind of doing Apple things. And let's see. Oh, yeah. Access control, yeah. But what actually happened here is that we got a connection from someone who wants to download iOS apps. And they really want to connect them. But something happened with the man in the middle. But we shouldn't be able to see this. So we intercepted a connection from an iPhone with a certificate we just created. This was the pwned. And if anyone wants to connect to my Wi-Fi after the talk, feel free to. And you shouldn't be running iOS 12.5, nevertheless. But it's the latest version you can get for iPhone 6. So if you're running iPhone 6, then don't download apps on connections you don't trust. And yeah, there's actually someone downloading an iOS app. I think it's most probably this one. Yeah, there is a download now going on. But let's cancel that. Because I'm actually logging the whole download, so there will be gigabytes of downloads. Let's kill this. I think I'm going number 8. Yeah. So we had the log that we wrote. So let's see what we caught. So I ran this already at home a little bit. So if we check our logs, there are different kind of things that we have downloaded. It specifies like how we downloaded it, and it gives us who downloaded it. So not only iOS 12.5, but also 14.3 is vulnerable to this exploit. Let's see. Yeah. And of course, when I discovered this, I downloaded an app and tried to push the app to the device. But if something is Apple does things kind of securely by default. So Apple is not trusting that when they are downloading the apps, they are not trusting that these apps are actually kind of delivered securely. So I can see this data, but if I do something, if I try to kind of push a different app that it doesn't want, it will just terminate the connection. It's checking all kinds of signatures on the kind of apps themselves, and I couldn't get any further than this. But still, you can, if you're running this exploit in your country or in your workplace, you might want to see that if someone is using the work time to buy some kind of love apps or whatever, or then if someone is maybe kind of downloading some kind of illegal apps in a specific place. So this was promptly fixed by Apple, and now when you are downloading apps from Apple, they should be encrypted with TLS properly. But I'm not sure if there's kind of tells you a little bit about the companies, but when I hacked Intune, Microsoft Intune certificate validation, I could just put whatever I wanted into the Windows. So when you are creating applications or whatever, you might not really want to trust the TLS connection. So if you are doing something kind of really important, like installing things on the computer or changing its configuration or settings or whatever, you might want to kind of put another layer of encryption on top of that. So even if someone can get in the TLS tunnel, they can't change those. Or if they get into the server, they can't kind of tamper with the data before it's sent to the user. I think I have another demo. Let's see. Are we on number 9? Yes, so this is called Start DHCP Server Windows. So we are using this DHCP server again. Now we want to capture this TLS test.do.fi, and we also want to capture client config.passport.net and redirect them to our IP. And we are intercepting the connection now with our Let's Encrypt certificate. So we have a certificate for TLS test.do.fi, and if something comes to that, we are getting the connections. And if something comes to client config passport.net, we are also using the let's unblock the Apple. We are also using the same TLS test.do.fi certificate for also that. And if we start up this kind of minor operating system called Windows 11, we can see what happens. So there are some things from the iPhone. Let's wait for the Windows to make a connection to our network. So here we have the desktop, and it's getting an IP from us, and it's starting to connect to the world. So let's see. Yes, it's always. Sometimes you might want to update, especially after this one. So let's see. It's taking its time. So now we're starting to see. So it's checking the time. It's checking some kind of traffic information. And then it's asking for something. Let's see. So Windows doing Windows stuff. Let's see, skip buddies. Yes, so now it's connecting to a bunch of stuff. And we have client config, so it wants to connect to that, and yes, that's not supposed to happen. So it wants to connect to this. Something is not correct. So it should have connected here. I think there's something wrong with this. But what it's supposed to do is that when it connects to client config, it should try to download something from us. So we have the POC. So we have this kind of file, this configuration file. And this is behind the client config.passport.net. So there is a file that has a bunch of information. So it has kind of miscellaneous information, such as what domain is used when we are resetting our password, what domain is used when we are using our accounts, and what domain is used for like pretty much everything. So this is Windows checking like where everything is. And you could use a certificate for whatever from Let's Encrypt to pretend to be this server giving this file. And if we modify it a bit, I just put TLS test.do.fi into everything. So when Windows wants to do anything, it will connect to this one. So yeah, pretty much everything. So, and what we will see, because we own this domain, we have a certificate for it. Everything else that Windows does, it doesn't matter if it validates the certificate correctly, because we own the domain. So if we can change these files, then we can change the domain. And this was a problem in Windows 10, 11 server, every Windows out there. So when you boot it up and connect it to internet, it will fetch this file insecurely. And let's see if we have this one. Yeah. So for example, when it logs in, it will connect to tlstest.do.fi and send the username and the secret password. So you can still, even though it didn't really work, you can still clap if you want. So there are these kind of problems in these minor developers, such as Apple and Microsoft. In this basic thing, TLS certificate validation, that is the kind of core of TLS. So it's half of TLS. And in the abstract, it said that this is the kind of most dangerous code in the world. And there's actually a scientific publication titled The Most Dangerous Code in the World. And that came out in 2011. And it said that, hey, when you are using kind of TLS from non-browser applications, you really need to focus on this. So this was 12 years ago when this kind of was known that how big of a problem this was. But still, this was, I don't know, start of last year that there was this problem in Windows, the kind of most used operating system, at least in the business area or whatever. And these iPhones that there is kind of billion pieces floating around in someone's pocket. So let's see if we can get back to this. Yeah, let's use this one too. We are about here. We went through this and we have demo. Yes. Sorry about that. But that was the demo. And if you want to kind of know more, these are not the only 3 CVEs I have for this problem. So there are lots more. And I think some that are coming out quite soon. It just requires for the vendors to actually fix them before I can talk about those. But also there are some public things that I'm missing from this presentation. But I think what I wanted from this is to say that, hey, it's pretty simple stuff, it's pretty important stuff, and it's broken everywhere. And if you are working with TLS, I hope most of you are working. Some parts of your job is requiring TLS. So I think I will publish the slides and this kind of command pack, so you can try this out yourself against kind of whatever you are building. And I think a good resource is this kind of website called Bad SSL. So if you are creating products and you have kind of unit tests for stuff, you might want to add kind of connection to this kind of wrong host .badssl.com. And this is a valid certificate with, let's see, what is the problem? It's valid for another website. So this is kind of good resource to get kind of good, bad certificates. So you can run your unit tests against this or create some stuff internally. But that was pretty much it. I hope you are scared, maybe a little bit kind of anxious to get home and kind of put everything into flight mode or whatever. But if you want to talk with me, you can find me at the after party, at Nixu, at LinkedIn, challenge.fi. I think that might be down currently. I am the kind of webmaster of that, so let's see if I can fix it. And in bug bounty circles, I go around with this handle Aapo. And if you have any questions, I think this is the kind of correct moment. There is a microphone there, so just raise your hand if you are curious about anything. Here's in the front.
Why would you be so evil as to put... Why would you be so evil as to put let's encrypt and GoDaddy in the same sentence?
Well, so I think the question was that I had... So I had GoDaddy and Let's Encrypt in the same sentence. So that's... Yeah, so I think I have used GoDaddy as an example because it's everywhere. So I had an example at some presentation and I checked a website for some cybersecurity company and they had a certificate from GoDaddy. But that's basically it. But I want to point out that there are good and not so good places to get certificates from, but there are thousands of places where you can get them from. Yeah, so you can get certificates from lots of different places and those are, yeah. Anything else?
You talked about the fact that TLS specification does not specify what the key in the certificate can be used for, but wouldn't the key extension, usage key extension that is specified in the TLS specification cover that already?
Yes. So the question is that I said that you can kind of put pretty much anything into the certificate and you can use the key for pretty much anything. And yes, you are correct that there is this kind of field in the certificate that states that this key or the key of this certificate can only be used for validating servers in the internet. And that is kind of in the specification of TLS, but it's not in the specification of the certificate. So it's just data that says that, hey, this kind of key should be used like this, but it's not mandatory. And in some implementations of TLS, it's missing. So this is kind of, or it has been missing at some point in the time. So I think there was a problem in early 2000s that you could use your certificate to sign any certificate. So if you get a certificate for aapo.com, you can sign a certificate for google.com. It wasn't checked that there, this restriction was there, but it wasn't checked. So when I say that there's it's not mandatory, then I just mean that not everyone checks it. So of course, you could do this correctly.
A small follow-up. I think that at least the X509 specification does specify the key usage extension. I don't know about the other certificate specifications.
Yeah, so it specifies it as an extension. It's not in the kind of original. And the extensions are not mandatory. So you don't have to kind of use the extensions. So it might be there, but it's not kind of mandatory field, or it doesn't have to be checked. But yeah, but I think if you have any more questions, I'm available after this talk. We can talk a little bit. I think I will be somewhere over here in just a minute. So come find me here or after.